So now that we have understood a little bit about what magnetism is, we're going to see if there's a way we can draw a picture that represents a magnetic field. A magnetic field. And so in order to do that, let's remind ourselves what a field is in physics. A field is a region of space or an area that is affected by or that has an effect on a particular property or a particular characteristic. There are many types of fields in physics. There are electric fields, there are magnetic fields, there are strong nuclear force fields, and all kinds of things. In fact, you may have seen in science fiction or heard of a force field. Well, a magnetic field is a kind of force field because magnetism is a force. So we're going to talk about a magnetic field. Let me write that in a different color. A magnetic field, then, is a region of space that does two things. It affects magnetic things, things that have a magnetic quality or personality, magnetic things, a magnetic characteristic, and it is affected by, affected by magnetic things. So what that means is something like a magnet is a magnetic thing, right? And if you put a magnet out somewhere, then all of the space around it will become affected by the magnet. And it will create a magnetic field. But you can also use a magnetic field to make something happen to a magnet. A magnetic field might make a magnet move, or push it, or twist it, or spin it, or turn it, and so on. So the magnetic field does things to magnets, and magnets create and do things to magnetic fields. Okay, so we're going to start by drawing a picture here of a simple bar magnet. That's kind of the thing that everybody can appreciate, a bar magnet. So let's draw a little bit. Something like that, I guess, will work. And we'll move it over into the middle a little bit more. Maybe move it down a bit and get some more space around it. Perfect. Okay, so this bar magnet is going to have a north and a south. So we'll give it a north pole and a south pole, right? And we talked about how those names originated in the last video. Now the funny thing about magnetic field lines is that they go through everything. Magnetic fields are not just around objects, but they also are through and inside objects as well. And so if I draw a magnetic field, I can draw it like this, and a lot of books will draw it like this. But I'm going to draw it right through this magnet because there's magnetic field lines inside the magnet. And this way you can see one of the most important things to remember about magnetic fields. The lines we use to draw them are always loops that are closed. You never see a line without with an end. Okay? There's always going to be a loop. So I'll draw another line here like this. And I'm going to draw it underneath here nice and carefully so that it forms a loop. And then I'll pick maybe one more. And around we go again. Forming the loop. Right? Those loops are a little bit messy there. See if I can't fix them up. Okay, not much better. And then what we'll do is we will draw maybe a loop on the other side. So we'll go sort of around like this. And we'll keep that in. I'm going to have to make a little more room there, and I won't fit them all in. Okay. There, come nice and close to the bottom. And then maybe we'll try and do another one like this. And I'll try to get one more, so there's 3 on each side. Around like that. Okay? Now, there would also be more loops. After a while, the loops get so close together, like they get concentrated. These loops would keep on going, like this, and sort of like that, in the middle. They'd be very concentrated. Now, what do these loops mean? Well, this is sort of a way of getting a picture of what the magnetic field looks like. And a magnetic field, because it has an effect on magnetic things, if I were to take a little compass, what I'm going to do here is I'm going to draw a little compass about that big, okay? And I'm going to put a little red line inside for the north pole of the compass. Except not there, because that's going to be not in the middle. I'll try and do that again. And then I'll put a little blue line for the south pole of the compass. Kind of like that. Okay? Good. And I will... So the blue is the south and the red is the north. Now what I'm going to do is I'm going to take this little compass and we'll stick it all together here. And now what I can do is I can move it and I can turn it. So I'm going to take this compass and I'm going to bring it over here next to this field line. Maybe right above it so we don't get confused. What will happen is the compass will feel this magnetic field line. Now, the direction of the field line is hard to describe. When you're outside of the magnet, it goes from the north to the south. So there's a direction associated with these lines. But of course, since they're loops, when you are inside the magnet, they kind of go south to north. So there's really no way to perfectly describe them. But if you think about outside the magnet, north to south, the best way I find to describe them is by using this little compass. So watch what happens now. If I take this compass, what he will do is he will twist himself around like this, and he will line up so that his north is lined up with the field line, right? Just like that. And if I make a whole bunch more of these, I can press this and press copy, and then I can press paste, and I can press, well, I'll move them over here. And then I'll make some more here. Let's make a bunch more. Paste, another one, paste, another one, paste. There, we got a whole bunch of these little compasses now. If I take one, like this one, and I bring it over here, next to this field line, well, it will twist, and it will line itself up as if it was right on the field line, like that. Okay? In fact, if I move it over, that's what it would do. It would line right up on the field line. Now you can't see the north and the south, so I'll move it back over just a little bit so you can see how it lines up. Okay? And then I'll take this compass over here, and if I were to put them down here on this guy right here, let's put him right in here. Well, what he would do is he would line up like this. You see how it's going the other way? Because we all know that north is pointing to south. North attracts south. So the north pole of my magnet, my little compass, which is the red, is sort of pointing towards the south pole of the big bar magnet, right? And if I take this guy over here and I bring him, let's put him right here. Well, what he would do is he would line up like that, almost as if he was right in line with the field line. Now, if I take a compass, if it's possible for me, it's impossible to stick a compass inside a magnet, but if I could somehow go inside there and put a compass there, well, he would line up in the same way. He would still point. Now, this is the weird part. You're like, well, why is the north pointing to the north? Well, he would line himself up this way because that's the way the field lines are going inside. So you see, it's hard to give a direction to something that's in a loop, but that's sort of what would happen. All right? Okay. So what this means is that around this magnet, things that are magnetic would be affected by this field. They would line up with the magnetic field wherever they ended up being. In fact, if you take iron filings, iron is actually tiny magnets. And if you put iron filings, little bits of iron, all over the space around a magnet, they will line up and they will show these exact field lines. And I have a picture of that we did here in the classroom that I will post as part of this video, but you'll be able to see that. But in fact, I think right now I can just zip over to the internet. Give me 2 seconds to find you a picture, and I'll be right back. Okay, and I'm back in a few seconds of your time, but a few minutes of my time. And here is a picture of a magnet. What this is it's a piece of white paper over top of a magnet. So the magnet is underneath. But you can kind of see the magnet there. Let me get a different color pen, and I will show you a couple of things. Let's see, yellow should show up pretty good on that dark picture. So let's go back to that picture now. And you can see that there is a magnet right under here. Oh, I don't want to do that. What did I do? I need my pen. Oh, because my pen's not on. Sorry, 1 second. I'm still getting used to this part of it. I need to get my pen here. Got it. Give me a second again. All right, I think I've got it now. You can see here I'm drawing. This is where the magnet would be under the paper. And then on top of the paper, they've sprinkled little tiny blobs or little tiny bits of iron, ground up iron. And what happens is the iron actually lines itself up as if it was made of little magnets. And you can clearly see a picture, sort of something similar to what I was trying to draw. This is actually a better picture. But you can see these field lines that continuously go around, and they go outside the picture, and they go around like this. And you can actually see that shape right in the iron filings, you see? And of course, these lines also go right inside the magnet and around and around and around. So they're complete circular loops. I'm just not drawing the ones inside the magnet, right? So inside the magnet, the lines are very tight together. See how they're very dense and compacted? That means the magnetic field is very strong. Outside, with all this extra space here in between, they're not so strong. The magnetic field is not as strong. And the reason for that is because these outside here, these are in the air. And air is not very magnetic, but inside the magnet, these are inside the iron of the magnet. And iron is a very good, a very, very strong magnet. It forms a very strong magnet. It's iron. Okay? So that's kind of a picture in real life of what we're actually trying to draw. So it's not just something we made up. We can actually see it if we sprinkle iron filings on a magnet. It will actually make the picture for us. So we know that the space around the magnet looks like this and is affected by this. Okay, let's go back to our picture then, and our magnetic field. And we're back here. Okay. Now, let's draw a couple of other pictures just to kind of see what might happen. A couple other examples. Let's see what would happen if we drew two magnets together. Let's extend this page a little more. Okay. And let's draw two magnets. Let's put one magnet over here and another magnet over here. And then let's call this a north and a south and a north and a south. Well, we know that these two magnets would be attracted to each other. Now we want to see what the field would look like. Well, it's going to look very interesting. We're going to get a picture that looks something like this. The field lines will travel between something like that, and they'll go around. Now remember, they're complete circles, but it's very hard to draw complete circles. And then you will still have the field lines here around this part of the magnet. I'm just drawing the ones on the outside, right, like that, and like this. And you'll get a funny-looking magnetic field that looks something like this, all right? I'm going to see if I can find you a picture of that one. Okay, so I found one here, and it looks something like this. I can't actually open the picture because it won't open, but at least we can see here what happens. Now, we don't know whether this is a north or a south. It doesn't really matter. This could be a north and a south, or it could be a south and a north. The trick is they have to be opposites. But if they're opposites, look at the pattern that's produced here. You can see it looks very much like the picture that I just drew. At least this part does. You can't see the parts over here that are starting to go back this way because this is too close up. But you can definitely see the magnetic field lines here in the middle of what an attraction looks like, right? The two different poles. The field lines are all linking together almost like fingers. And you can almost envision them, fingers that would be pulling something together. All right. Now, if you look at this other picture that they have here, I'm going to see if I can't click that other picture to come up right here. Then I'll clear off this ink. This is a different picture. This is what you would get if you had a North Pole and a North Pole, or a South and a South. This is a picture of two similar poles. And you can see the picture, it looks like the field lines are going like this. It's almost like they're bumping up against each other and they're pushing away. And right here in the center, there's very little field at all, almost nothing. And then they kind of pushing around like this, heading outwards like that. And this is why this is where we would see a repulsion. The two north magnets would push each other apart. So this is a picture of that. And what we'll do now is we'll just go and draw one, just like we were doing with the other. So here's ours. Let's go down a little bit, and maybe I can select this, and I can copy it, and then I can paste it twice. Get two more magnets. There we go. So let's take this guy down here. I think we have to go a little further down. Let's take him down here like this. Let's go around the other guy right here. I can grab him and bring him down here. And so when you have two poles that are the same, like a north and a north, or a south and a south, the field lines go up, out, and they make this interesting pattern that looks like this. And in the middle here, there's virtually no field at all. There's nothing happening there. I don't want to put that circle there because it looks like it's a field line. And it just basically means there's nothing in the center of this. And this is, of course, two poles that are similar and they repel. So you should sort of get your eyes focused on what this looks like right here, two poles that are the same, and over here, what this looks like, two poles that are opposites. Okay? Awesome. And so those are some simple pictures of magnetic fields. And if you Google magnetic fields, you'll get all kinds of pictures, as we saw here. We'll clear off this ink, and you can see that, clear the ink there, you can see a couple of different pictures. This is a pretty good one. There's lots of diagrams. If you look up here, you can see similar pictures to what we just drew, something very close to what we just drew. Here's an interesting picture. We'll come back to this picture right here. It shows the magnetic fields around all kinds of things. We did a magnet, we did this one, and soon we will learn about the magnetic fields around coils of wire like this one, and a single wire like this one. Here's a picture of Earth's magnetic field, which we already saw. So you can see that the shape of the field is very different depending on what's causing it. But for magnets, they all tend to look the same. You can see a lot of the pictures here that look the same. Okay. So we'll stop there, and I'll give you a little assignment where you can practice drawing some magnetic fields, and that's good enough for that.